Okay, tutorial, finding meaning in curved graphs. Alright, I'm gonna show you two ways to find meaning in these graphs. The first way is gonna be the very detailed numerical way that I've been teaching you. And another way is a slightly shorter-hand way to come up with that. So I guess I will just start with an X versus T graph. I'm trying to make it as these divisions as precise as I can, because if the divisions are off, my data is going to be less accurate. So, and this is either you call it, I've called it the box method before, or the interval to interval analysis. Alright, so the interval, I'm going to make this time go by 2's. I'll make distance go by 4's for its position. Alright, so first of all, let's do a curve that goes up. So what we're doing here is we're analyzing basically different multiple intervals of the same amount of time. What does that mean? That means first we pick a time interval. So why don't we make it easy and say every 2 seconds. So we will look at the change in X every 2 seconds. So let's do that. So at 2 seconds, these are the, this is where the line is. So if we're focusing on the X, we're focusing on the vertical part. So that means at 2 seconds it starts here, and then so this much is how much height it gained. Alright, it's very little, it's pretty hard to see still, but it'll get better when we check the next 2 seconds. So this is where the line is, or the curve is, at 6 seconds. And so between 4 and 6 seconds, this is how much it gained. And now at 8 seconds, the curve moves up to here. And it had gained this much position in the from 6 to 8 seconds. So from 8 to 10 seconds, if the graph is now, if the position of the curve is now there, it's gained that much. And now 10 to 12 seconds. So it starts there, it ends up here. Alright, and how we see a progression. What kind of progression? Every 2 seconds, the position, I won't say that, I'll say the change of position gets larger. Every 2 seconds, the object travels further than the previous 2 seconds. All right. And if you travel farther in the same amount of time, so notice that our intervals are every 2 seconds. So if you travel further in the same amount of time, you are moving faster. All right, so this object is therefore, and you know this by velocity is displacement over time. If you actually do delta x over delta t for every, and this is the average velocity. If you do use this equation, delta x over delta t, for every single 2 second interval, you're going to find out that the average velocity in each interval will increase. For example, this is like 1 meter per second. And if I skip to the end, this is like 6 meters per second. And I'd assume that everywhere in the middle, there's just an increase and an increase and an increase. Well, that's what it looks like from the arrows that we drew. So that's kind of the idea. So if it went from 1 meter per second at the beginning to 6 meters per second at the end, then we know that it's sped up. So this graph, this curve, describes an object's motion with a positive acceleration. All right, now let's try another one. So let's get ourselves a table. X T and then I'll go by fives here. 5 seconds, 10, 15, 20, 25, 30, 35, 40. And I'll go here by ones. 1, 2, 3, 4, 5, 6, 7. All right, so let's do a different looking curve. Let's do a curve that it starts out at 7 meters, so it starts out far away from the reference point, and then it behaves like this. So let's do an interval by interval analysis. So interval by interval. So the first thing I do is choose my interval. My interval (5-second intervals). Use 5-second intervals. And then let's do it. So I'm not gonna start at 0, just because it's harder to read really close to it. I mean, you can start at 0 seconds, but I'm gonna start at 5 seconds because I feel like it might be easier. So between 5 and 10 seconds, that is my first interval. So let's see how far it drops. So it starts at starts right here, and if I go across, I see that this is now dropped. It has dropped that much. It's like it looks like 1.5 meters. So this is dropped 1.5 meters. All right, and the next one at 15 seconds, it starts here at 10 seconds, but by 15 seconds, it's gone down here. So this is dropped about 1 meter. All right, and then here, all right, this is dropped a little less, maybe 0.8 meters. It's getting harder to tell now. All right, between 20 and 25 seconds, it started here and dropped down to there. So that's like probably less than 0.5 meter, 0.3 meters. I can't even write it anymore. And then let's do one more. And that's like almost nothing. And then this is almost nothing too. And then after that. So by here we see a progression. So what do we see? What do we see? We see that the change in position, that the delta x change in position or displacement gets smaller from one 5-second interval to another. So if delta x gets smaller, by v equals delta x over delta t, v average, it travels slower and slower from interval to interval. Okay, but from here, what direction is this going? All right, notice how direction. To find out the direction, well, we need to know, well, what is its initial velocity like? How fast is it going and in what direction? Initially, it is going fast. and negative. All right, and if we went and looked up at the graph, this way is negative. All right, if this was going up like the first graph, that would be positive, but this object is traveling towards 0. Starts at 7, ends up at 0. So initially it's fast and negative. At the end, it is very slow and barely negative. It's almost stopped, and of course once it's stopped, it's no longer negative. So the velocity gets less negative and is and so the direction of acceleration is positive. Okay. Yeah, so the velocity change, because the velocity gets less and less negative, that would be a positive velocity change or a positive acceleration. Okay, that's all the examples of that I can do. Now, shorthand. This is only really good after you really get the longhand or the longhand. After you really get this stuff. But basically, steepness of curve means fast velocity, and let's switch that around. Means large, steep curves. You know, I just have to re-say this all together. Steep slopes for an x versus t graph mean steep slopes for an x versus t graph mean high velocity. Flat slopes for an x versus t graph means low velocity. And graph going downward means negative velocity. graph going upwards means positive velocity. Okay, so I will give you examples for each of them. So we've got this one, we've got this one. These are the two positive velocity graphs going upwards, and then we have this one, and then these are the two negative velocities because the graph is going downwards. All right, so to analyze these graphs, okay, first we really need to know how does the slope change? If we look at the slope at, say, a point in the beginning, say right here, if we want to know the slope at this point, we make a tangent line basically. And we see that it's like that. It's pretty vertical. But if we take a tangent line towards the end, it's very horizontal. That means here it's fast, here it's slow. And all the time, positive velocity. Because the graph is going up. All right, so if you have a positive velocity that is going from fast to slow, well, it's becoming less positive. So this is a negative acceleration. All right, the change in velocity is going from fast positive to slow positive. So it's becoming less and less positive, and that's a negative acceleration. This is also a deceleration because it's getting slower and slower. Deceleration. Okay, next one. All right, we'll do the other positive one. In this case, if we look at a point at the beginning and do a tangent line, we see that the slope is pretty low. Later on towards the end, we see the slope has gotten more steep. It's higher. So the slope increases, the steepness of slope increases over time. All right, and now, besides that, the direction. Well, it's positive the whole time. So direction, velocity is positive. So what does this say? If the steepness is increasing, it's going faster. And if the velocity is positive, then we have a situation where the velocity is going faster and faster in the positive direction. So this is a positive acceleration. The velocity is becoming more and more positive. I might as well add into here velocity is becoming less and less positive for the first one. All right, last two, we're gonna have to squeeze these in. All right, for this one at the beginning, very steep. This one at the beginning, not steep at all. So we have a negative velocity. We have fast to slow, So this is, velocity is becoming less negative. Which means positive acceleration. All right, and last one. It starts out not very steep at all, and it ends up pretty darn steep. And so we have a negative velocity again. Let me change colors. Okay, so we have negative velocity. Then we have slope. It goes from slow to fast. Sorry. Slow to fast. Therefore, it's becoming more and more negative. So that would be negative acceleration. Oh, and I forgot for the last one. Because it's becoming, it's going from fast to slow, it is decelerating. Anytime something goes from fast to slow, it decelerates. It doesn't matter its direction. All right, and that's the shorter hand. So for the practice problems, I want you to do both ways. I want you to first do the long way, and then I want you to do the short way. So practice. Okay. I'm making it easy to do. At least I'm trying to. Okay, so we'll start with this one. This isn't straight up. That's not good. That's going to mess up all of my data. So let's try that again. The shape of your graphs really do matter. Okay, so number 2. All right, 3. And 4. The good news in all this is there's really only 4 shapes other than if it's a straight line. For the curve graphs, there's only 4 shapes. So if you know these 4, then you're good. Okay, those are your 4 problems. Use interval by interval method. Verify your answer using the shorthand method. Each method you should get the same conclusions. All right, good luck.